Hello, class. So happy to see you again. Good morning, good afternoon, good evening, depending on what time of day you're watching this virtual class. Let's begin. Today, what we're going to do is we're going to do a theoretical activity about levers. Now, in class, we've done several practical interactive activities and demonstrations about how levers work. Now, let's review before you go into the activity. Remember, the instructions say that you should cut out each of these squares, and then you should also decide which square you should put them on top of, or paste them, or glue them on top of. In this case, you have three options: A, B, and C, and you also have three possible answers, which is easy, difficult, or medium. Now, I put them in different order so that you can be a little bit more tested as to what the right answer is. But I know you're going to do it fantastic. So, let's begin. Let's look at lever A. So first of all, let's review by identifying the several and various parts of a lever system or mechanism. Here we have always, for a lever, obviously, we need a lever. In this case, we can call it a stick. A stick or a long piece of material that is very hard, very stiff, and able to support a lot of weight. Most of the time, these levers are going to be either made of wood or metal. So, here we have the lever. In every single lever system, you're going to have a fulcrum, which is going to give you support from the ground or from the surface that you're using to lift the next part of the lever system, which is the load. In this example, we're using a load of 1 kilo. Now, that's a very light load. In class, you saw how we were able to lift up 30 kilos, 40 kilos with just 2 fingers by manipulating the position of the fulcrum. Let's review. We have then the force. The force is the energy that we push down against the lever to make the load go up. See, every lever wants to make the load go up. So let's review the basic principles of a lever. Now, the efficiency or the strength of a lever is determined by its length. Here I highlighted the length of the functional lever in orange. The functional lever means the distance between the force that's applied to the fulcrum. The force that's applied to the fulcrum and the force that's applied to the fulcrum. Now, to help you through this activity of cutting out the squares and gluing them to easy, difficult, or medium, fácil, difícil, or medio, dificultad media is the last one, I believe. You have to think, okay, Joseph, I remember, the longer the lever, the easier it is to lift the load, which means the less force I have to apply to lift a very heavy load. If you remember the classroom experiment, we had moved the lever closer or further to the load. Very good. We moved the lever closer to the load. We moved the fulcrum closer to the load, and that's why we were able to push down with 2 fingers to watch our classmate be lifted, or the load be lifted. So, my question is this lever long or short? Is this lever long or short? Is this lever long or short? The longer the lever, the easier it is. The shorter the lever, the more difficult it is. So, with that being said, cut out each of the 3 squares and glue them on top of the options. Now, the last step that I detailed in the instructions is for you to label, just like I did here. Let's use this example, please. You need to label all 4 parts of the lever simple machine system. This you need to label as force. This you need to label as lever. This you need to label as the load. And this you need to label as the fulcrum. I'm going to write down all the key terms right here, just so you're able to see how they're written, even though on your worksheet you have them written again with the brief definition. Okay, so let's begin. Force is written F-O-R-C-E. Lever is written L-E-V-E-R. Fulcrum is written F-U-L-C-R-U-M. And last but not least, the load. L-O-A-D. So, good luck, everyone. I'll see you next week.